Hi guys, I'm Arun Valliyappan. So today we'll be solving the LeetCode Weekly 396's first three questions. They're going to be string questions. Let's dive into them. So the first question is valid word. You see, you're given a word and you're told the conditions that make it a valid word. So the conditions are, let's say if you're given a string S of A, B, C, D, the conditions are it contains a minimum of three characters. Then it consists of digits, uppercase, lowercase in English letters. And he also mentions not necessary to have all of them. And then it includes at least one vowel and one consonant. So how many conditions are satisfying over here? The length is over three characters. It consists of 0 to 9 digits, uppercase, lowercase letters, and not necessary to have all of them. So this is also true. It includes at least one vowel and one consonant. We have a vowel A and we have consonant B, C, D. Consonants B, C, D. So can I say that this is a valid word? Yes, we can say that this is a valid word. Also, if I had a 9 over here, still it would be valid. But what if we had a dollar? So there is nothing mentioned about a special character here, right? And if you see, let's deep dive into the examples. If you see the first example, word 234 ADAS. So this is a true because it has more than three characters. It has a vowel. It has a consonant. And what about B3? This fails the first condition itself. The length is less than 3. And what about the third case, A3 $E? So here it says that this word contains a dollar character and it does not have a consonant as well. So if you observe, they mentioned that it consists of 0 to 9 digits, the uppercase and lowercase English characters, but there is nothing mentioned about special character. Hence, if we have a special character, it is not a valid word. And if you see the constraints tell the word length can go up till 20 and the word consists of English uppercase and lowercase letters, digits, at, hashtag, dollar. So we have lowercase letters, uppercase letters. We could also have digits, we could also have at, we could have hashtag, or we could have a dollar. So now, okay, let's deep dive into another string. Let's say A, 9, capital A, C. Now, what about this string? Firstly, it has more than three characters. So, one condition is satisfied. Second, digit 0 to 9. The uppercase, lowercase English letters, yes. And the second case is also satisfied. It includes at least one vowel. A is a vowel. It could be a small a or a capital A, doesn't matter. And at least one consonant. So it also has a consonant. So all the conditions are satisfied. Hence, this is a valid string. Now, if I had a hashtag over here, then I need to say that this is invalid. So how do I first analyze if the current string has greater than three letters? I could simply use n, where n is nothing but s dot length or s dot size. So if n is less than 3, then I'll return false. Next, how do I check if it is an uppercase or a lowercase letter or a digit? Now we know that an uppercase letter, let's say s of I, if this is an uppercase letter, then it should be greater than or equal to a character, a as a character, and it should also be less than or equal to z as a character. Likewise, for a lowercase letter, this should be greater than or equal to a small a as a character. Likewise, it should be greater than or equal to lowercase z. Now, what about a number? S of I should be greater than or equal to 0 as a character, and it should also be less than or equal to sorry, this is less than or equal to, likewise less than or equal to 9 as a character. Now if my character does not belong to uppercase, does not belong to lowercase, and it does not belong to digits, I can say that it is a special character. And since we are specified that these are the only special characters that are going to occur, then I could also simply check if s of I is equal to either at or dollar or a hashtag. S of I is equal to a hashtag. So if my character belongs to any of these, then what can I do? I can simply return a false saying that this is an invalid word. So my first check is going to be on what is the size of the string. Next check is going to be, is it a valid character or an invalid character? Now if it is an invalid character, I am simply going to return false. And if it is a valid character, I now need to check if it is if our string has at least one vowel or one consonant. Sorry, and one consonant. So what can I simply do? I could simply put a check if my S of I belongs to capital A, capital E, capital I, likewise O, U. Likewise, I can do the same in case of lowercase letters. So once I see that my character is an uppercase character, I'm going to check if it belongs to the vowels. Now, if it belongs to the vowels, I take that as I have at least one vowel. And if it does not belong, then I'm going to say that it is going to be a consonant. Likewise, I need for lowercase as well. So what can I do for lowercase? Instead of all uppercase letters, I'm going to use lowercase letters. So if these are the cases, then I can consider that I have at least one vowel. Now in the else part, I can simply consider it has at least one consonant. Clear with the explanation? Let's move on to the code now. Alright. So moving on to the code. Now firstly, I need the length of the word. So word dot size. What next can I do? I need to first check if my size is greater than 3 or not. Now if it is greater than 3, I can continue. When do I stop? If it is less than 3. Even if it is equal to 3, it satisfies the contains minimum characters case. So if it is less than 3, then I know that this is an invalid string, hence I return false. What comes next? I need to somehow make sure that I am storing this vowel or a consonant, or the presence of vowel or a consonant. Now, when it comes to presence, I can simply use a Boolean variable. Let's say vowel. Initially, I take it as false, and likewise consonant. Again, initially taken as false. Now, I need to first iterate through the string so that I can access the characters. Hence, for int I equal to 0, I less than n, I plus plus, the first check is going to be, is my character an uppercase letter or a lowercase letter or a number? Now, do we have any significance for numbers here? No, right? There is no condition that I should at least have one digit. So I can ignore the digits. I need if it is an uppercase letter or a lowercase letter so that I can check for vowel or a consonant. So if word of I is greater than or equal to capital A and word of I is less than or equal to Z, then it means that this is an uppercase letter. Now else if word of I is greater than or equal to lowercase a and word of I greater than less than or equal to lowercase z, then this is a lowercase character. Now else I can check if it is a digit or not, and else comes our special characters. But now that we know what are going to be our special characters, that is at, hash and dollar, we can simply check if they are either of them. Now else if word of I is an at, or word of I is a hashtag, or word of I is a dollar, then what do I do in that case? I simply know that it is an invalid string, hence return false. Now, what do I do in case of an uppercase and a lowercase letter? I need to check if it is a vowel or not. So, if my word of I is equal to A, or word of I is equal to E, or equal to O, sorry, I, or word of I equal to O equal to U. If this is the case, I know that this is a vowel, hence I'll make vowel as true. Now, else part, what do I do in case of it not being a vowel? Then it is a consonant. So a simple else is sufficient, else consonant equal to true. Likewise, I need to do for lowercase characters. So let's just simply copy paste this. Now, instead of uppercase letters, I need to have lowercase letters. So let's quickly change it. Vowel equal to true, consonant equal to true, that's it. And if it is neither of them, and if it is the special characters, then return false. Finally, what do I return? Can I return true directly? No, right? My conditions are I definitely need to have one consonant and one vowel. So if my consonant is not true, and or my vowel is not true, or my consonant is not true, it means that either my vowel didn't occur or my consonant didn't occur. So in that case, what do? I simply return false. Now otherwise I can return true. That's it. Let's quickly run the code. Sample cases are cleared. Let's submit it. Done. All right. So let's quickly move on to the next question. So the second question is going to be minimum number of operations to make a word k periodic. So let's firstly understand the question. Now you are given a word of size n and an integer k such that k divides n. That is, one thing is for sure, there are two variables n and k given such that n percentile k is 0. It is mentioned that k divides n, hence the remainder is going to be 0. Now he tells in one operation you can pick any two indices I and j that are divisible by k, and then replace the substring of length k starting at I with a substring of length k starting at j. That is, replace the substring word I to I plus k minus 1 with substring j to j plus k minus 1. Now you need to return the minimum number of operations required to make the word k periodic. So let's consider an example, whatever is given here. A simple example provided to us here is the word given as leet code leet along with a k value 4. So first thing is, what is the length of the word? The length of the word given is 12. Now is this divisible by k? Yes. So as mentioned in the question, this is going to be divisible by k. So what do we do next? We are told that in one operation I can pick any two indices that are divisible by k. Now what are the indices divisible by k? If I take the indices, I'm going to get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are the indices, and from these the indices divisible by k are, can I say 0 is divisible by k? Yes. Likewise 4 is divisible by k and 8 is divisible by k. Now I can pick any two indices, let's say L and another L at 0 and 8 positions. And in one operation, after picking, I can replace the substring of length k. What is the length of k? So the first four characters, can I say? Right. So the first four characters, and I can replace it with the substring starting at j, that is these last four characters. So you can pick any two indices that are divisible by k, then replace the substring of length starting at I with substring of length k starting at j. So if I replace this here, I'm simply going to get the same word because both the substrings are same. So let's consider a different example, that is 4, this time 0 and 4. So what happens now? Now my LEET and CODE will be changed to CODE, CODE, LEET. Yes. So after performing one operation, I'm going to get this word. Now he tells return the minimum number of operations required to make the word k periodic. Let's see what he means by k periodic. We say that a word is k periodic if some string s of length k such that word can be obtained by concatenating s an arbitrary number of times. That is, he has given us a example a b a b a b. The periodic string for this is going to be AB, because by concatenating AB thrice, you are getting this string. So I can also say that AB, 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 that is concatenated 4 times, is also a k periodic string of length 2 of the string AB. Likewise, what if I had S equal to CODE? I'll get a string CODE or CODE, CODE or CODE repeated 3 times. So these are all my k periodic strings of strings A, B and CODE. So we are asked to return the minimum number of operations required to make the word k periodic. Now we have performed one operation. What more operations will I need to convert this string to a k periodic string? One more operation could simply be choosing I at L and J at CODE. Now, if I replace this, what am I going to get? I'm going to get CODE here as well. Now, can I say that this is a k periodic string? Right. So, for the given value k, we have made the string as k periodic. And how many operations did we take? The first operation converted the first four characters and the second operation converted the second four characters, which means the number of operations here came out to be as 2. Is there a simpler way? So if you observe, our strings starting at k positions or k divisible positions are these, and I see that LEET has occurred twice. And how many more partitions are there? Only one partition is there left out that needs to be converted. So ideally, what would be the optimal number of steps to convert this to a k periodic string of string as LET? Simply a single step. A single step is sufficient. So by this, what do we understand? We understand that if we somehow get all these k-sized strings or k-sized substrings from the given word, and that too not overlapping but continuous case-sized substrings from the given word. I need to just find what is the substring that is occurring most number of times. Now, if I know that, I'm just simply going to convert all the other partitions to this substring, right? Simple as that. So, what can I simply use to make this work? I need to maintain a string along with its number of times that is occurring in the given word. I could simply go for an unordered map or a hash map. So an unordered map of type, the key is going to be of type string and the value is going to be the number of occurrences. So it would be integer. I could also use, in case of Java, I could also use a hash map of type string to integer. That's it. Now all I need to do is I need to iterate through every k characters and insert that into my hash map. Once I've inserted that into the hash map by maintaining its count, I can finally iterate through the hash map and take out what is the maximum occurring string. Or I could also simultaneously take out the maximum occurrence by maintaining an extra variable, a couple of extra variables you can see. So let's look into the code implementation now. Alright, let's quickly write the code. So first we need the size of the string. So word dot size. Now what do we do? What do we need next? We need an unordered map to store the k-sized substrings and their occurrences. So of type string and int. And let's take the name as hm. Now firstly I need to start iterating through the string such that I land at every k divisible point. So we start with 0 and we go until n, and how do I directly reach this every k divisible point? That is, it should be like 0, k, 2k, 3k, so on and so forth. So I can simply increment my k, increment by my I by k every time. Now I have attained the first step. Next, I need to get this k characters starting at I. So let's take a string temp equal to empty string. Now for int j equal to I, j less than I plus k, and j plus plus. Why are we taking j equal to I, j less than I plus k? We need the string starting at I and of size k, right? So if we start at the ith index, then if I increase the k characters, then it will go until I plus k minus 1. So less than I plus k. What next? I need to take these characters into the temporary string. So temp plus equal to word of j. And once this is done, I first need to check if the string exists in my hash map. So hm.find temp. If it is equal to the end of the hash map, then it means that this does not exist in my hash map. So hm of temp is going to be 1. Now otherwise what do I do? This already exists in my hash map, so hm of temp plus plus to increment the existing value. That's it. Now with this, can I say that I'm going to have all my k-sized substrings along with their counts in my hash map? Right. So now I need to iterate through this hash map and take out what is the maximum occurred substring, what is its number of maximum occurrences. So to keep a track of the maximum number of occurrences, let's take max number of occurrences. Max number of occurrences is going to be 1. Why is it 1? Because if it is in the hash map, it means that it must have occurred at least once. So the least value could be 1. Hence we are taking it as 1. Now auto entry equal to hm.begin, then entry should not be equal to hm.end, and each step entry plus plus to move to the next value. Now, where will my number of occurrences exist? It is going to be in entries second part. So this entry second part, I need to check if it is greater than the max number of occurrences. If it is greater than, it means that this string is occurring more times. So if this is true, then max number of occurrences is going to be equal to entries second part. What else? With this, I'll have the max number of occurrences of the string, of the k-sized string. Now, how do I get the number of partitions that I can make of size k? I'm given with a string of size n. Now, from this, I need to get the number of partitions of size k. So, a simple way is just n by k, right? The n by k will give me what is the number of partitions. Now, from this, I know what is occurring the max number of times. So, all the other substrings should be made to this string. Hence, the number of partitions to be converted using the operations are n by k minus whatever is the max number of occurrences. I simply need to return this value. Let's quickly run it. Alright, it has cleared the cases. Instead of this, you could also use the substring function. So it's up to you. Now let's quickly submit and check it. Alright, accepted. Alright, let's start with the third question now. Now the third question is minimum length of anagram concatenation. So you are given a string of size, string s, which is known to be a concatenation of anagrams of some string t. You need to return the minimum possible length of string t. Now an anagram is formed by rearranging the characters. So simply if you take a, b, a, c as your string, one of the anagrams could be a, c, b, a, or it could also be a, b, c, a. It could be any permutation of the given string. So if these are your permutations, the string that can be made by these are ABAC, ACBA, ABCA. This is the way in the question he is constructing the string S from the from some string T. That is the anagrams of some string T. So what is the one thing that is clear? The one thing that is clear is whatever is the T string, let's say the T's length is M, M is T dot size, and let's say S's length is N. M should be dividing N, that is N percentile M gives us a 0 value. So this is one thing for sure. What else do we understand? We just somehow need to find out the minimum possible length. Now, if this is the given string, is there any other way or is there any other anagram that causes this string? So a simple example to understand what does he mean by minimum possible length is to understand what does he mean by minimum possible length is if the given string or if the t string is ABAB, the other permutations could be ABBA or AABB. Let's leave this last one for some time. So A B BABA, right? So if I join all these three strings, what is the string I'm going to get? If I concatenate these ABAB, ABBA, BA, BA. Now you might think that straightforward 4 is going to be our answer, but we need the minimum possible length of T, which means can I take AB as well as the competent for the answer? because AB or BA are permutations. They are nothing but anagrams. So since AB and BA are anagrams, I can say this string is formed by T is equal to AB as well. It does not always need to be ABAB. It could also be formed by AB as well. Now for a change, if you take ABAB, ABBA, and AABB. Now if you take this, can you consider AB as your valid answer? So if you consider all the pairs, you see that you get AA and BB as well. So T equal to AB cannot be an answer for this string. In this case, what will the answer be? Simply 4 will be our answer. So for this case, the answer would have been 2. And for the second case that we have considered, it would be 4. Let's try to understand the given example outputs as well. So there are two example outputs given as ABBA. Output is 2 and explanation is one possible string could be BA. You could also consider AB as that is also the anagram. What about the example 2? Example 2 is CDEF and the output is 4 because one possible string T could be CDEF and we are unable to find any other string T that could be concatenated or whose anagrams could be concatenated to form the given S string. So indirectly, what do we need to do? If we are given with a string, firstly I need to know what are the numbers that satisfy this condition. Now, what all numbers can satisfy this condition? M is nothing but the factor, can I say? M is factor of n. M is a factor or divisor. So I need to first keep a track of what are all the divisors so that those are all going to be my uh, competitors for the answer, you can say. Now among all of them I need to find what is the minimum answer, right? So if the given string is 12, what could the possible m be? M could possibly be 1, it could be 2, it could be 3, could also be 4. What about 5? 5 cannot be there because 5 is not a factor of 12. So what could it be next? 6, 7, 8 cannot be, 9 cannot be, 10 cannot be, 12. That's it. So these are all going to be my competitors for my answer. Now since I need the minimum answer, I can simply iterate from the least to the highest. And in each iteration, what am I going to do? Let's say m is equal to 1 is our first case. So for m is equal to 1 and the given string, let's take the given string as this. So for the given string, if my m is 1, I need to first check are all my one length substrings same or not. And here as well, like the previous question, I need the substrings in a continuous manner, not in an overlapping manner. So I first, can I take what is the first substring? After taking the first substring, every other continuous substring should be an anagram of this first substring. So how do I qualify two strings as anagrams? I can simply check their sorted orders, or I could also take their count arrays. Now, since it is easier using the count arrays, let's go for count arrays or hash maps implementation. So first I take A, then for the leftover characters, I need to simply iterate and check every m sized substring. So I start my iteration, I see that B is my next string. Now, is the hash map of A and B same, or can I say that A and B are Anagrams? Not at all. So if this is the case, if the first substring itself did not match, do I need to check all the other substrings? Not required at all. Not required at all. So can m be my answer? Sorry, can my 1 be my answer? No. So since it is not my answer, I'm simply going to increment my m value. Now at 2, what do I need to do? The first step is again constructing the hash map based on first two characters so that I can check every other two character substrings. So my hash map would be A1, B1. Now for all the leftover characters, I need to check every two character substrings. So what happens here? I iterate, and what do I do with this? I create another hash map. Let's say this is hm1 and the other hash map, that is also going to be a1 b1, and let's keep this as hm2. Now are hm1 and hm2 same? Yes, they are the same. Why? Because they are having the same key value pairs, hence we can classify them as same. Now we are only checking the values, we are not checking the references. So since the first substring is right, what do I do next? I need to check what is the next substring. So this is checked. What about the next substring? It is again going to create the same hm2. Again I'll compare. Again, since they are same, what do I do next? I iterate to the next substring of size 2. Again, can I say that the same values will come up here? Yes. So likewise, for the other two substrings as well, I'm going to obtain the same value. And once I reach the end of the string, what can I say at this point? At this point, I can say that whatever is the last m I stopped, that is going to be my answer. And since I'm iterating from minimum to the maximum way, whatever is the first point I stop or whatever is the first point I reach the end of the string, that is going to be my answer. So at that point itself, I can simply return a false. And how do I skip to the next m value? I can maintain a flag when I turn it to false when the substrings are not anagrams. So let's quickly jump into the implementation part. All right. So let's start with the implementation part. Now, firstly, I need what is the length. All right, let's quickly start with the implementation part. Now, firstly, I need the length of the word. So s dot size. After getting the length, what do I do? You're given a string s, which is known to be a concatenation. Yeah. So what do I do next? I need to know what are all the factors. Now to know what are all the factors and to store them, I can use a vector of type integer. Let's take as factors, and let's simply write a function to fill in the factors. So let's take a void function, void factor fill. What is the n I need to fill in the factors for, and what is the vector I need to fill in. So I'm taking ampersand vectors, that is, sorry, ampersand factors, that is, I'm passing the reference of whatever is the variable that is going to be filled or whatever is the vector that is going to be filled. So firstly, I start an iteration I equal to 1, and I should go until which point? I can go up until n by I, can I say? Yes, and it can also be I less than equal to n by I, because for let's say a perfect square value 100, the last factor is going to be 10 10, that is 10 into 10 will be 100. So at this point, if I write less than, I'm going to stop even before I reach 10. So to continue, I'm going to take less than equals to. Now, if my n percentile I is equal to 0, it means that I can perfectly divide n. And at this point, how many factors am I obtaining? I'm obtaining two factors, that are I and n by I, right? So I need to push in these two factors. So factors dot push back I first, and then factors dot push back n by I next. So let's say if the value n is equal to 6 and if my I is 2, 2 into 3 is going to be 6. So at that point, how many factors am I getting? I'm getting 2 as well as 3. The thing is, I need not go up until 3. I can stop at the square root value, which is going to be less than 3. Now, if my n percentile is not equal to 0, do I need to consider that? No. And like we saw for the case 100, I need to push only one time, right? I need not push twice. If I push twice, it is going to make my numbers 10 and 10 as well. I mean, if it is going to make my factors include both the 10s. So I need to check if my I is equal to n by I. If this is the case, what do? I simply push either of them, that is factors dot push back either of them, else I can push back both of them. With this, can I say that all my factors will be filled in the factors vector? Right. Now I need the minimum to maximum traversal, which means I need to sort this. So sort factors dot begin and factors dot end. So after sorting, my factor fill function's logic is done. I need to call this factor fill function from my min anagram length to fill the factors vector. So factor fill, what is the n value? The size of the string, and the vector to fill is factors vector. So with this, my factors vector is going to be filled. Now what do I do with this factors vector? I need to iterate through this vector and I need to check if it satisfies the given condition. So for int I equal to 0, I less than factors dot size I plus plus. If this is the case, I need to use this number as factors of I. Since I do not have anything to do with the value of I here, I just need I do not have anything to do with the index. I can simply use a for each loop. So int factor of factors. Now I need to traverse for every factor length, or for better understanding, let's take k over here. So I need to traverse through every k sized string or k sized substring in a continuous manner. So just like the previous one, I can take for int I equal to 0, I less than n, I plus plus, no, it is going to be I plus equal to k. This is going to get my every k characters start. So what do I do from this point on? I need to fill in my hash maps, and to check, firstly, do I have the first hash map that I was talking about? That is, we had hm1 and hm2, right? So do we have the first hash map? No. So for that, I first need to iterate through the first k characters. So int I equal to 0, I less than k, I plus plus. I need the hash map, so map of type unordered map of type character to integer. Let's take hm1. In C++, you can simply do it as hm1 of s of I plus plus. So if s of I is not in the hash map, it is going to take the default value as 0 and create a new entry. If it is there in the hash map, it is simply going to increment the value. So with this, my HM1 is going to be filled. Now, if the first k window or k substring is considered, where do I need to start from next? My first window's indexes would have been 0 to k minus 1. So if I start from k, wouldn't that be sufficient? It would be sufficient. And I need to iterate through this current character to k characters from there, right? So how do I do that? Just like the previous question, for int j equal to I, j less than I plus k, j plus plus. And for every start index, I need a new HM2, right? So unordered map of char to int type HM2. Inside, I simply need to do HM2 of S of j plus plus. Now in C++, it is simple to compare two hash maps. So if HM1 not equal to HM2, it means that the first k characters is not anagram of whatever is the current k characters. So if that is the case, do I need to continue further? No, right? When I find the first discrepancy, I stop it there itself. No, I need to break. But then how do I know if I broke because of this condition or was it because of the successful condition? So for that, as discussed, we need a flag variable. So flag initially, let's keep it as true. Now if it is not equal to, it means that the flag should be turned to false. Now after exiting this loop, if my flag is true, what does that mean? My flag is true means that all the hash maps had equal values. That is, all the k substrings that all the k sized substrings that I generated are all anagrams. If that is the case, that is, if flag is true, what can I do? I simply need to return whatever is the current value of the factor. That is k in this case. Now, if my function does not execute for, sorry, if my for loop does not execute for any factors, what would be the by default return value I need to return? The entire string would be the case, so return n. But would this statement really be required? No, right? Because n itself is a factor. So n is a factor of itself, that is. So definitely this condition is going to be executed. But since the compiler requires a return value, and since we know that the default value is n, we are going to write as return n. Now let's quickly test our code. Accepted. Let's quickly submit it. Done. That's it. Alright guys, hope you liked the video. Smash the like button and subscribe to Smart Interviews for more such content. Thank you. Arun signing off.